Math 119, this last section of chapter 11, 11.3, ANOVA, one-way analysis of variance. This section is kind of important because, for what I understand, some of the university, when you transfer to 4 years university, they normally ask you if you have had these sections on your stat class. So in that case, you could always say, yes, you did have that sections, and that was a part of Math 119 class. So in this section, we introduced the method of one-way analysis of variation, which is used for test of hypothesis. Now, this is the time that you do the test of hypothesis for 3 or more populations. We normally deal with 2 populations, entire chapters, all the sections, but now we are dealing with 3 or more than. If you want to claim the mean for 3 or more population, then you're using one-way analysis variance. So here, your HO, or the null hypothesis, is mean 1 equal mean 2 equal mean 3 in case you are dealing with 3 populations. And there are some conditions that the analysis of variance, they call it ANOVA methods, require the F distribution. So here, the type of the graph you're using is the F graph. And on this one, the alpha is this area here. You have better pictures if you go to your textbook, find a better picture for this one. And then there is a different F distribution for each different pair of the degree of freedom. F distribution is not symmetric. You know, it's like a chi-square. It's not a symmetric shape. It's skewed to the right. Value cannot be negative. You always start from 0 and increase to positively. So it's always positive. And the exact shape of distribution depend on 2 different degrees of freedom. There are 2 types of degree of freedom that we discuss later for this kind. So when testing for quality of 3 or more population mean, use this method. One-way analysis of variation is a method testing for equality of 3 or more population mean. And there are some conditions. I put the conditions: a population have distribution that approximately normal, population has the same variance, and sample are simple random samples, independent, and so on. But the null hypothesis is this one. This is the one that you need to remember. HO is, it depends how many population do you have. Our HO is they all are equal, they all have equal mean. All populations have equal mean. This is an example here that in the textbook. In this example, they say the important environmental health study involved children who live within 7 kilometers of the large one smelter in El Paso, Texas. Smelter is used to melt the ore in order to separate the metals in it. Because this smelter emitted lead pollution, there was a concern that the children would somehow suffer. So here they have three set of informations. Performance of IQ score of children, low blood lead level, medium blood, and high blood. So the claim is use the performance IQ score listed in this table, and significant level is 0.05. That's basic for most of the problems. Test the claim. So in this example, the claim is that 3 samples all come from population with the same mean. So original claim happened to be our HO. Null hypothesis is that all populations are population means, they all are equal. So here, this is your HO, and HA or H1, alternate hypothesis, if you could prove that at least one of these population mean is different from the others. So, and then we try to use the technology for this. And this is the result of the technology. And I'll show you on the next page, I'll show you the calculation for this. that here, if you happen to have a sample, if the sample means are all very close to each other, then you end up having a small f and large p-value. If you have at least one sample mean is different, then you should have a large f and a small p-value. So test statistic for one-way ANOVA is this. F, which is the test statistic for this section, is the variance between samples divided by variance within the samples. The numerator of F-test stat measure variation between sample means. The estimate of variance in the denominator depends only on the sample variance and is not affected by difference among the sample mean. Consequently, sample mean that are close its value to each other result in a small f, which is a case like that. So sample means that are close in value to each other, the result is always a small f test and a large p-value. We conclude that there are no significant difference among the sample mean. Sample mean that are very far apart in value, result is large f test and small p-value. When you use the calculator eventually will give you the value of f and the value of the p. And then you could tell which one of these two graphs is related to your problem or examples. And I guess you understand it based on the example that we have. Okay, here we want to calculate table 11-12 can be very helpful in understanding the method of ANOVA. In this table, compare data set A to data set B to see the data set A is the same as data set B with this notable exception. Sample 1 value each different by 10. So what's the difference between these two is just the sample 1, if we add 10 to all this, we have these numbers. So here what we want to discuss, first we want to discuss data set A and calculate F value for just these numbers, okay? So we are taking three sample from 30 different populations, and these are the numbers in each samples. For these numbers, there are 4 numbers on each. We calculate the mean for each and variance. You remember variance is standard deviation to power of 2. So whatever the standard deviation is, the variance is s to power of 2. Means if you take a standard deviation and raise it to the second power, that gives you the variance. That's why you have here s to power of 2. All right. So what I did on the next page, I'll show you how we do the calculations. First, the best way to do this problem is use your calculator, okay? If you want to use your calculator, what you do is, you are dealing, this is just for data set A. In data set A, you are dealing with 3 separate lists. So we left, so the first one we input it into our L1, this is L2, and this is L3. And then you could use the calculator for those. Let me see if I have that here. See on your calculator here, under edit, you have all these numbers under L1, these numbers under L2, and these numbers under L3. Then you go to a stat test ANOVA. So this is a stat test, and then you go all the way to the bottom, and that's where you could find ANOVA. Now you list all your number in L1, L2, L3, you have to use a comma and separate them. So it would be second, L1, comma, L2, comma, L3. Okay, so ANOVA L1, comma, L2, comma, L3. When you do that, you find the F is 0.1428 and p-value is 0.87. And if you notice here, there are two values of DF. We discuss this later on. See the DF2 and DF9. Remember these two numbers, DF2 and DF9. Okay. All right. So that's how to do the calculation using TI-84 calculator. If you want to do the hand calculations, the way to do it is for each of these. For each of these, you find your mean and standard deviation or variance. Okay. So for the second list, you find the mean and the variance. The standard deviation to power of 2 is the variance. And then you take average of those three. What you do is first you find the average of these three mean, which is 5.5, 6, and you take the average of these three. And also you find the variance of these three. You could also use your calculator. You put all this into like L4 and calculator under calculations like here. So you calculate variance, and then NSX2 means you find the variance and multiply by how many numbers you have, 4 at each column. You should also calculate average of 3 variance. This is the power of 2 is the average of 3 variance that we already have, 2, 2, and 3. Then the formula is this. F is N times average of variance for these divided by average of variance for the mean. That would be your F value. Okay, so again, you calculate, you take these three numbers, which are 3 sample means. You take these 3 numbers. For these 3 numbers, you calculate the variance, which is this, and multiply that by 4. That would be your numerator. For the denominator, you use average of 3 variance. So you could do all this. This is the way to do it, hand calculation, or use the calculator. And all this is explained on this page. I have a copy of this for you. So what it is here, you'll notice that the p-value is 0.87 and F is 0.14. This 0.87 is p-value, which is greater than alpha. This 0.87 is greater than alpha, which is 0.05. Anytime your p-value is greater than significant level, you do not reject HO. You accept HO when p-value is greater than alpha. So in that case, you accept HO and HO indicate that all three means are the same. This is what HO is. So when you have a small f and the large p-value, then sample mean are very close, and then we fail to reject equality, so we have to accept the null hypothesis. Okay, so this case is what we have in this example here, which is on this page. See, so when you do the ANOVA using a calculator, if your p-value is greater than alpha, then do not reject HO. And HO happen to be this. Now here we also calculate critical value. On the next page, I show you how to calculate the critical value. To calculate critical value, we are using F distribution table. F distribution table has 2 degrees of freedom, one here, one here. On the example, we had 3 samples for the data set A. See, for data set A, there were 3 samples. Sample 1, sample 2, sample 3. This is your K. K value is 3. And how many numbers we have here? You have 4, or 4 is 8, and 4 is 2. That would be your N value. So this kind of problem, there are always 2 DF. One DF is K minus 1, which is 2. The other DF, they call it DF within. This is DF between. DF, degree of freedom of within, is N minus K. N is 12. There are 12 numbers to deal with. And 3 is the K. So it would be 9 and 2. So D of within, you find it here. And D of between, you find it at the top. And this gives you 4.26. And that's the number that is the critical value. So for your graph, that's the number that you have on the graph here. This is what you have here. All right. Here is another example. I picked this from one of the textbooks that show you how to do. If we ask you to find a critical value, this is how to do it. This is a very simple example. There are 3 set of the numbers. 1, 2, 3. Each has 3 numbers in it. So HO is, we claim that all three population have the same mean. And HA, which is the H1 or HA, the same thing. If we prove at least one of the mean is different, then we could reject that. Alpha is that. Now, this is just to calculate the critical value that you have on the graph, on this one. This is the F that you find through the graph. So for that, there are 1, 2, 3 category. So that would be K. N is how many numbers we have here? We have 9, 2 and 6. So there are always 2 degrees of freedom. And this 2 and 6, you just go and find that on the tables. See here? should be 6, and 2 should be 5.14. 5.14. So this number 2, you find it here, and 6 here, that bring you to this one. That's how to use the F distribution when alpha is 0.05. All right. So this is how to use the calculator. We discussed this at ANOVA. And when you go through the homework, there are just a few problems. These, I think you should be able to go through it, and I'll let you go and put the answers there. That which one of those is correct? D, because the p-value is less than, if the p-value is less than, if the p-value is less than significant level, what you do? You always reject HO, and if it's greater, you accept. This example is a good example because it asks you how to calculate the HO, H1, F, and p-value. Again, these are the informations. For the king size 100 millimeter mental and non-mental, 3 set of numbers are given. What you do, you input all these L1, these L2, and this is L3. Okay, and I have those. So you go to your calculator here, and you input all 3 of them here. See, L1, L2, L3. So you list all those 3 numbers under L1, L2, L3. And then you go to, again, stat, go to test, all the way to ANOVA. Oh. All right, and then now here you put L1, comma, L2, comma, L3 that. See, it gives you these numbers that you have here. Your F is that. This is your p-value. And if you notice your p-value, which is 0.03, is less than alpha. When the p-value is less than alpha, then you always reject HO. Okay? And the rest are just a multiple choice, and you should be able to look through those. So this is the last sections of Math 119.